Hello, my name is Malinee, and today I'll be showing you my final report for my optimization final project. As a quick problem recap, soda is primarily sold in the form of a weight-gaining good, meaning shipping costs increase as the cargo load and shipping distance increase. To solve this problem, our company Buzz Cola is working to optimize the profitability of our soda distribution network. We'll be using a model of a loaded delivery truck, which we'll be using MATLAB to solve for. So to define our model, our objective function will be profit margin, which is the ratio of revenue to expenses, and our design variables are the cargo load of the truck in terms of the number of cans loaded onto it, with the given variable C, and the delivery range of the truck with the given variable R. To further define those functions, revenue is defined as the number of cans sold times the sale price of each can, where the can sold is just the variable C, and the sale price is a function of the delivery truck range, R. To define expenses, that is the sum of the production cost and the shipping cost, where production cost is considered a function of cans C, and shipping cost is a function of can C and delivery range R. To model the sale price of a can of soda, we operate under the assumption that a consumer who is farther away from the production facility may be willing to pay more for a can of soda than a consumer who is closer to the production facility. So to this model, we have the function as shown, which the multiplier term in the function should create a sale price of $1.50 per can, approximately 125 miles from the production facility, which is about halfway between St. Louis and Kansas City. The function is subject to the constraint of the sale price must be greater than the minimum price, yet less than or equal to the maximum price. For this model, we've taken the minimum price to be 50 cents and the maximum price to be taken as $3.90. This is the estimated cost of a 12-ounce can of soda at Busch Stadium, which theoretically should be the largest amount of money a reasonable person should be spending on soda. To model the production cost, it is simply the number of cans sold, C, times the unit cost of a can of soda. We estimate the unit cost of one can of soda to be 10 cents per can, which assumes all relevant costs in the production process. To model the shipping cost, we use the function as seen that uses the variables miscellaneous truck cost, fuel cost, and efficiency. Miscellaneous truck cost accounts for things like driver pay and insurance, and that's estimated at 35 cents per mile. The fuel cost is taken as the national average of diesel fuel costs and is estimated at approximately $4.17 per gallon. The efficiency factor accounts for the decrease in gas mileage due to an increase in cargo load in the truck. So that's defined as the base mileage, or 6.5 miles per gallon, minus a load drag. And the load drag is the number of cans sold times the unit weight times the drag factor times the base mileage, with those definitions seen below. Finally, we add in load capacity, where the total weight of the cans must be less than or equal to the total load capacity of the semi-truck, which is estimated at 48,000 pounds. And the delivery range must be greater than 50 miles from the production facility, but less than or equal to 500 miles. To solve this problem, we will be using MATLAB, with the primary function being fmincon, and linear constraints were used to accommodate the sale price function. From our optimization results, we can see that the maximum profit margin found was approximately 13. Our optimum delivery loadout would be that the truck would have a range of 126 miles and would be loaded with approximately 14,200 soda cans. Some additional data points of interest were that the sale price of one can would be $1.51. The cargo weight on the truck would be 11,085 pounds. We would see a fuel efficiency of approximately 2.9 miles per gallon, and we could expect a profit of almost $20,000 per delivery truck. Some observations and further considerations. The optimized number of cans on the truck is most affected by the unit weight of the can. Drag factor played a major role as well, but that should be relatively constant across trucks and other vehicles. The unit cost really had little to no effect on the optimized number of cans. In terms of delivery range, multiple variables had noticeable effects. The most notable were sale price, miscellaneous truck cost, and fuel cost, but those could vary significantly based on market conditions. All other variables were pretty constant throughout all other types of vehicles. For future expansion and optimization, our company Buzz Cola can look into the deployment of electric vehicle fleet to minimize energy costs, changes in our packaging to maximize the amount of soda sold, and marketing strategies to increase our sale price closer to our production facility. And here we have our references for our data and optimization, and thank you for watching.